All right, 9b, the 68 to 95 to 99.7 rule. Okay, when we talk about all these rules, they only apply to normal distribution. What it's saying is, statistically, your mean is in the center, and 68% of that sits between the first score and the score to the right of your mean. The first score being the one below mean. Okay, so let's say in our class, it was a test out of 100. The average happened to be 50%, and the standard deviation was 5%. So when I say the standard deviation is 5%, it means that from the mean, on an average, the difference from the next score was 5%. So technically, if the average is 50%, the person who got below 50% actually got 45%. And the person who got below 45% was around 40%. And actually, as you go, you notice you're going down by fives. Now, again, standard deviation is the average. It could realistically be that the next person under 50 was actually got 44%. So there's a difference of just one, and the next one would be a lot more. So, yeah. Then the next type of graph is, well, what happens if it's two lots of your standard deviations? Then you actually have 95% of this part in the center. And if it's 3 standard deviations away, it's actually 99.7% in the center, and the remainders are on the left-hand and right-hand side. Okay, this will make a lot more sense when we use numbers. So we're going to start straight away with question 11, because I think that one shows it the best way. So the story is that it's about fruit, and on average, a bag of 10 of the blood plums from a orchard have a mean of 1.88 kilograms, and a standard deviation is 0.20. So on average, it's 1.88, and the next one could be either 0.20 below, take away 1.88, or it could be above, so 1.88 plus 0.20. Now, you have all these questions asking about percentages. Before you do any of these questions, you actually need to make a graph out of them. So similarly to this here, okay, we're going to make all these graphs, but instead of mean, we're actually going to have our mean written in it. And instead of mean plus 1 standard deviation, we're going to have those numbers as well changed. Two numbers changed. All right, so on my blank piece of paper, I'm going to draw one standard deviation graph. So that means, remember when we talk about normal distribution, it's just a graph that sits like this. The most highest point is in the center, which is your mean. And from the story, we got that the mean was 1.88. Now, because we have to go one standard deviation to the left, it means we just go, the next mark will be whatever your mean was, take away your standard deviation. So when you work out the next part, you do mean, take away your standard deviation. So mean was 1.88 and our standard deviation was 0.20. Okay, we're going to use a calculator for this simple thing, but oh well. One standard deviation is 1.68. So that means one of the bags, actually most of the bags were at 1.88 because that was the mean, but the weight that was under 1.88 happened to be 1.68 on average. Okay, that was the next to lowest weight. Now, the next highest weight from the mean is mean plus your standard deviation. So 1.88 plus 0.20, which gives us, again using a calculator, 2.08. Okay, so that means when you work out your one standard deviation to the left and one to the right gives you, and the book says, the rule itself says, it's 68%. Okay, so this, all of these, so most of my bags, so 68% of those plum bags, 68% of them sit between this and this weight range. Okay, the remainder, whatever it is the remainder of whatever is from 68 to 100. So that is 32%. Okay, half of 32% is 16% on this side and 16% on this side. So all this is 68%. Everything less than 168 is 16%, and everything higher than 2.08 is 16%. Resembles this first standard deviation graph here. Okay, that is the graph for only one standard deviation. I'm going to answer the first question straight away so you actually understand why we drew the graph and why it makes sense. And then I'm going to draw the second standard deviation graph and the third. So our first question was, what percentage of the bags of 10 plums weigh 1.68 and 2.08, sorry, between those two numbers. Those two numbers sit right here, 1.68 to 2.8, and as we noticed, one standard deviation was 68%. So my answer for question 1, that between 1.68 kgs to is actually 68% of the bags. Okay. Now to do the rest of the questions, you will notice that we actually don't have those numbers graphed. I don't have 1.28 and I don't have 2.48. Okay, I don't have them graphed. So to graph those, we actually end up drawing the, we draw this one, we draw that one as well, and then we start actually understanding how we work out the percentages of those.